welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. Today, I'm talking with Nisim Lavowitz about cloud-native geospatial, but not the usual satellites and petabytes version of that story. We're talking about what happens when you bring cloud-native down to the level of a small city with no budget and the world's slowest internet connection. Nisim spent 9 months in Argentina doing exactly that, and along the way found 3 million people who don't show up in the country's own census data using a spatial join that runs in about 3 seconds. You want to know how he did it? We'll get into that in this episode. Before we get into it, I want to say a quick thank you to the people making this episode possible, the Cloud Native Geospatial Forum. The CNG Forum 2026 runs October 6th to the 9th at Snowbird, Utah. It's 3 days of real-world cloud-native geospatial, Stack, COGS, GeoParquet, ZAR, and more importantly, the teams who are actually developing these things at scale. It's not just theory, it's what's actually working. And if you want to get your hands dirty, there's a hands-on workshop day on the 6th. You can register over at 2026.cloudnativegeo.org, and I'll put a link to that in the show notes of this episode. Nisim, welcome to the podcast. We did it. It's been a lot of back and forth, but you're here and I'm really pleased to see you. So today I want to talk a little bit about cloud-native geospatial. You have a relatively interesting background. You've done a lot of different things, as I recall from our pre-interview, but maybe the best thing to do with these introductions is just to hand it over to you. Would you mind introducing yourself, please? Who are you? What do you do? And how did you get involved with cloud-native geospatial?
Yeah, absolutely. First, thanks for having me. Really good to be here. My background is in city planning, so I kind of came to geospatial through an AmeriCorps year with the city of Philadelphia. It's like a year of national service, and I was there during COVID and had a lot of free time on my hands, and started learning to program in R and got really interested in open geospatial data. City of Philadelphia has a great open geo portal, and I carried that interest over into a master's degree in city planning at the University of Pennsylvania, and I focused really heavily on climate risk and spatial data science and data analysis. And so that's really where I got very interested in this question of open data and how we can use it for cities to make better decisions. So in 2025, I got really lucky. I got to do a Fulbright research grant and go down to Argentina, where I spent 9 months trying to understand how smaller cities, under-resourced cities, especially in the global south, can use new open geospatial data sets to make better decisions about climate risk. In the last couple of years, we've seen this really cool proliferation of great open data sets at the global level. Up until pretty recently, it wasn't really possible to have really high quality, high resolution data sets to support local decision making. Data sets tended to be kind of national or subnational and not really at a high enough resolution to let people make real decisions. But in the last couple of years, thanks to deep learning and AI advances, we've just seen this explosion of really high quality data. And so I was interested in this question of how we could use those new data sets to help smaller cities that historically have not had access to data like that to make better decisions about crucial issues like climate risk. And I had this kind of crazy hunch that Cloud Native Geo was sort of involved in that, but I didn't know exactly how, and I couldn't have really articulated it at the time. But that hunch turned out to be quite accurate, actually, and that's sort of been what my career has turned into since then. So now I'm doing some contract work for Radiant Earth, trying to continue to extend some of that work that I did in Argentina and scale it up. So part of that is this GeoParquet.io work that I've been doing with Chris Holmes, and also this other project that Chris and I are working on with some folks at Carto called Portalon, where we're trying to build a cloud-native spatial data infrastructure. It's in a very early stage, but that's sort of the goal, is to make cloud-native more accessible to more people. And then generally trying to figure out how to scale up the work that I did in Argentina in 2025 to more cities and make that more accessible in a variety of forms.
So we're definitely going to come back to this work that you've done in Argentina. I want to start somewhere else, though. We've said cloud native a few times, and we've even mentioned cloud native infrastructure. What are we talking about? Are we simply talking about a file format? You mentioned Parquet. Is that cloud native infrastructure?
There are probably a lot of different ways to look at cloud native, and I'm sure lots of people have some pretty specific opinions on definitions. I try to stay away from definitions, in part because I'm not sure my technical expertise extends to that level of rigor, but I think it's more helpful to think in terms of examples. Cloud native has kind of emerged to handle really large volumes of data, and this is stuff that was coming out of like NASA and the European Space Agency, and they're moving around petabytes of primarily satellite imagery and that kind of stuff. And so I think the initial question that motivated it was we're sticking all this data in these cloud buckets on Google or AWS, and how do we make it easier for people to get access to that? But eventually that kind of evolved into a more particular set of questions around the advantages that cloud native offers in terms of things being really scalable, better compression, so data stores smaller. We get around issues with latency when you're trying to transfer really large volumes of data and that kind of thing. But for me, the number one thing that I think about with cloud native infrastructure is ease of access, right? And other people might have other things that they think about, but because I come from the perspective of working with small cities, for me, cloud native means easier to access. And this is particularly relevant when you're talking about global climate risk data sets, right? Which tend to be really, really large. You're talking about hundreds of gigabytes or terabytes or more of data sitting up in a cloud. But then you're a city and you probably don't need all of that, right? You don't need the entire world's worth of elevation data or land cover data. You just need the little chunk of that data that applies to your city. And so if you're thinking about a legacy approach, old school, not cloud native, you might need to download a tile of those data that might be 15 or 20 gigabytes, right? Which is prohibitive, especially because climate risk is layering stuff. The analyses tend to be really simple in climate risk. You're really just like stacking multiple layers, but in order to stack multiple layers where each layer requires you to download 20 gigabytes, you're downloading 100 gigabytes of files maybe for 5 layers that are core for your analysis, and that becomes, it's not tractable. You just can't do that. But the cloud native approach says, well, we can take advantage of this thing called range requests, and instead of downloading the 20 gigabyte file, we get the 100 megabytes that we actually need, right? So you don't have to download a tile that covers all of Argentina. You download just the chunk that you need for your area. And so cloud native infrastructure has a lot of different things that make it very valuable. But for me, when I think about the number one thing that I care about, it's that ease of access. You only download what you need, which unlocks all this access to global climate data sets specifically for local use.
Yeah, that's a really good explanation, actually. I think it really pulls it down to the ground. I'm particularly interested in you tying this to local data sets and government data sets. In the past, I know you mentioned this yourself, that cloud native kind of grew out of this need to, what the hell are we going to do with all this terabytes of data, petabytes of data we're streaming out of satellites on a daily basis, I guess. What are we going to do with it? But that seems to have quite a limited use case to me. Like, there's very few people building pipelines, but when we bring it down to the level of cities, of local governments trying to do work, I think it's a more interesting use case for me personally. I also wanted to add on to the thing you said about range requests. I mean, that does definitely improve the access. There's no question about it, because like you said, I don't need the entire 58 gigabytes of data. I just get this section that I'm interested in. I think it's also worth mentioning that it also lessens the burden on the host of the data. So they don't need this GeoServer instance running in the background serving out this data. They don't need some sort of massive Postgres infrastructure in the background either. It's just a file that sits somewhere that you can make requests up against. And that makes it a lot easier for them as well. Yeah, thank you very much for that. I appreciate the definition, even though you said it wasn't a definition. I appreciate it. Before we get into the rest of the conversation, let's talk about the work you did in Argentina and then try and tie that to cloud native. So you talked about getting access to these data sets. You talked about local governments doing work with climate risk. How does cloud native tie into that?
There are a couple different places it ties in. I think the number one thing is just connecting to the data. A data set that I come back to over and over again is the Open Building Footprints data set. And it's maybe a misnomer to say data set in the singular, because there are several different versions out there. You've got the Google and Microsoft and OSM and Overture and all that stuff. But regardless, I think that sort of core cluster of data products, I guess as Jed Sundwall would probably call it, is enormously valuable for a number of reasons. But it's, in particular, it's just so obvious to people the value when they see it, right? Because it has so many applications and so many different things related to planning. And I think historically, the obstacle there has been one of access, right? It's like people don't know it's out there, and people don't know how to get it, even if they know it's out there. So in the city of La Plata, for example, which was where I was based, I worked with their GIS team and the municipalities. They drafted their first ever comprehensive plan in the city's 120-something year history to use those building footprints to do an analysis of population in informal settlements and to try to better understand the spatial distribution of flood risk in those settlements. And we were able to pull those building footprints and show that there are probably 140,000 plus people missing in La Plata's assessment of informal settlements, right? So that's more than an eighth of the total population of La Plata. And pulling those data was just, I mean, you can load them in QGIS now, thanks to the GeoParquet downloader that Chris Holmes has put together, or you can load them in Python. But there are two levels of obstacle there, right? Like you have people don't know that the data are there and they don't know how to access them. And once I was able to show the municipal government how to access them, it's really easy to do stuff with them. You just load them right in QGIS and then you can do any number of things. We were just doing a spatial join for this analysis, right? And that runs in seconds. And that, I think, is the really cool thing here is like once you can figure out how to get the data locally, once you can figure out how to get it into people's hands, then all kinds of things become possible. So the bottleneck there really is the question of like, how do I efficiently access the data? And this was something that I ran into when I was initially playing around with the data for the first time. I was using DuckDB and trying to access this stuff. And I was learning GeoParquet and cloud native patterns as I went and realizing that like, if you don't know that a bbox covering makes your spatial queries way, way, way faster, or that pre-sorting with the Hilbert index will speed up your queries, I mean, that could be the difference between a query that runs in 2 minutes versus 30 minutes versus not at all. So, that is the slightly more nuanced answer because it is not just a question of like knowing it's out there, knowing how to access it. The knowing how to access it is still a little bit of a technically challenging problem if you don't have good documentation and good examples for how to do it. So that's a big part of what I worked on was trying to build that documentation and those examples to show people, hey, this is highly replicable. What you do in La Plata is the same as you do in Pergamino or Buenos Aires or anywhere else in the world. And so I'm still working on trying to build those patterns and kind of disseminate them to show people how easy it is to use these kinds of optimized spatial queries to really rapidly pull these data in.
So you mentioned Chris Holmes. He's done a lot of work in this area, and he's a really fascinating dude. And there's a lot of other people that have been working real hard to build this stuff into things like GDAL, into things like QGIS to create this access to the data. What have we done wrong? What's the missing piece then? Why are people still finding it hard to do if we have the technical infrastructure to do it? What's the missing piece? Where have we dropped the ball?
I would be mindful of saying drop the ball because I think that maybe undersells how much work we've already done. I think we're in a field where capacity is really limited. There aren't that many of us. And that's something that I've learned very quickly in this field. It's like you spend enough time here and you realize it's like 5 guys holding up the entire field, right? It's just 5 of us. Obviously that's not true. There are a lot of folks, but it is still a very small field relative to a lot of other kind of technical domains. And one of the consequences of that is like there's just not that capacity there to infinitely do educational work, capacity building and stuff. But if I had to pick one thing that I think is the next frontier maybe in how we close this adoption gap, because I think it is an adoption gap, it's education, right? We've done a really good job, for example, of building scientific education materials. I look at like Project Pythia, for example, or the EOPF toolkit, and that stuff is awesome. It's super cool. And that for me is a model of what we can do if we turn our attention to other communities now. I think we haven't looked at small cities in the global south, for example, because like newsflash, they have no money to pay for this stuff. And so historically, we've sort of been oriented toward paying customers and larger institutions like ESA and NASA that can contract us to do this kind of work. But I think we now have this really cool opportunity to scale our impact by expanding this audience. And, I say that because people in this field aren't in this field by accident, right? If we just wanted to make a bunch of money, we'd be working at very different companies. I think we care deeply about social impact beyond just the bottom line. And this, to me, is this incredible opportunity to scale our social impact, right? We've built this incredible set of tooling. There's this wealth of data out there. And the thing that is holding us back now from having social impact is not incomplete infrastructure. It's not lack of knowledge. It's literally just expanding who we're thinking about as our audience and working on better communicating to them. And I think we're already actually quite good at doing that education, that communication when we put our minds to it. So it's just a question of broadening that perspective.
I think too, this is typical of any sort of advancement in technology. It moves much faster than the cultural advancement, which needs to happen for people to really take advantage of it. Would you mind talking a little bit about those 2 toolkits you mentioned before? What are they? What's inside them? Can people go and use them?
Yeah, Project Pythia and the EOPF toolkit I'm not intimately familiar with the ins and outs, but I teach a course on remote sensing at Penn, at the University of Pennsylvania, and it's a course that I actually started out taking, and I learned a lot of what I know about DASC, for example, Xarray, pulling stuff through PyStack client. I learned that from Project Pythia and the EOPF toolkit and stuff. So those have been incredible educational resources for me, and I now use them to teach students at Penn. We recently, I gave them a lab on pulling Sentinel data in ZAR format for wildfire analysis over Portugal. And I think it's such a great toolkit. It's ESA and DevSeed, I think, and a couple of other folks putting it together. And it's a really good example of high quality educational materials with kind of cutting edge tech being applied to a real problem. And that's the kind of resources that I imagine us building, of pairing really good technical expertise with concrete domain applications. Because I kind of alluded to this earlier, the technical implementation is still a little challenging, right? If you don't know how to optimize your spatial queries, it can be a real obstacle. But if we can give people very clear tutorials or cookbooks of how to do this kind of stuff, that will go a long way in making it more scalable and allowing people to more independently tackle these challenges.
What would you say, and this might be a hard question to answer, what is the biggest benefit here when we think about implementing sort of a cloud native approach to analysis? Is it the performance? Is it faster? Is it the cost? Is it the simplicity? Is it something else?
Well, it really depends on your perspective and your user. It's a hill I'll die on, is that thinking about the user is you got to do that. But I think there's sort of two parts to the answer I'd give. One is that everything that we say about cloud native at large scale is true at small scale, right? So, I worked with municipal governments in the middle of Argentina on like the world's slowest internet connection. And I can promise you they care about latency, right? They might not care about it the same way that Earthmover does, but they care about latency. And they care about low cost and stuff. Like Chris and Javier and Cayetano and I working on this Portalon project, we envision a low to no cost cloud native spatial data infrastructure, right? Which is like, GeoServer, but potentially better. And if you're a totally broke municipality and you have no funding to hire Esri, for example, or contract somebody to put together your spatial data infrastructure, you care about keeping costs down, and that's totally valid. Feasibility, just that it's possible, right? That you're talking about municipalities that often don't have the capacity to collect their own data, right? Like if they don't have cloud native to connect to the global building footprints or something like that, there is no way they're ever getting these data themselves. So this is the difference between having data and not having data, and that's really crucial when you're talking about something like climate risk. So it's not just that, it's cheaper, it's faster, it's more scalable, but it's really the difference between having data to support good decisions and not having that data at all.
Let's say they did have some capacity, some resource to go and start building their own building footprints data set. It kind of flies in the face of what these centralized data sets are meant for, is it not? Like, we should be building on the shoulders of giants, if you will, as opposed to everyone starting from the ground up themselves. So yeah, that makes a lot of sense to me. Also, I guess if people are using the same data sets, maybe there's some kind of repeatability between the different types of analysis they're making. Maybe one municipality can figure this stuff out and give it to the next one, and it's repeatable there as well. And then they can compare the results, apples to apples kind of thing.
Right, precisely. And so that's kind of what I've tried to do post-Argentina, is compile my work into an open source toolkit. It's still very much a work in progress, but that's the idea, to show people sort of the core concepts of open data, climate risk, Python geospatial, robust decision-making, and then cookbooks with examples from my work in Argentina showing people how to apply the same methodology. And it's all open data, right? It's Landsat data and building footprints and global DEM models and stuff. And it's all extremely replicable and frankly, extremely simple. I definitely went through a period in learning data science where I was really excited about cutting edge deep learning models and stuff. And I still think they're really cool. But I find more and more that the simple approaches are often really powerful. Like I took this work that I did in La Plata on informal settlements. And last week, I scaled it up to all of Argentina because I kind of had this gut feeling that there was something there. And with just a spatial join in DuckDB that runs in, I kid you not, 3 seconds, you can see that there are 3 million or more people who don't show up in Argentina's census data, just based on building footprints. It's a spatial join, right? And there's no deep learning, there's nothing crazy there. It's existing data sets and a simple query. And that, I think, is the sort of the core value proposition here. Is like, once we connect people to these data, there's nothing incredibly fancy that they have to do. It's really high quality global data sets, very clear decision making, pretty simple spatial analysis that can have really powerful impacts in places that desperately need this data. I mean, Argentina just less than 3 months ago announced that under the current government, they're shutting down the institution that does their census of informal settlements. And so, I'm looking at that and then seeing this finding that I came up with and thinking like, this is kind of critical in countries like Argentina or countries, frankly, like the United States, where the independence of census infrastructure is under threat, and where there are big questions about our ability to reliably deliver robust data products to make these decisions. It's really important to have access to data products like this and to be able to do these kinds of analysis. And so I think in some ways, cloud native and these open data products are coming out at a time when it's really crucial to be able to provide this to a lot of countries around the world to better do climate risk planning and to be a little less reliant on the fragility of legacy institutions that are maybe no longer so reliable.
It's a real shame that we have to think like that. But, in terms of creating something that's more robust, we need to. Isn't it wild that like that 3-second query in DuckDB, all of a sudden 3 million people, their lives are represented. They are going to be taken into account when somebody does the analysis. That's insane to me. So when you're talking to a GIS person, you're talking to a GIS analyst and she's saying, well, what is this cloud native stuff? How do I do it? How does it work? Why should I care? Do you show them? Hey, this is how you do it. Do you teach them? Do you say, go away and read this article? What do you do? How do you convince them? Or are they all in from the start?
Yeah, well, there's definitely, especially in city government, there's this kind of institutional resistance to new stuff, right? There's this kind of sense of like, no, we don't want to rock the boat. That's too complicated. And I've seen that everywhere, right? I mean, that's something that you see. I've seen that working in Philadelphia. I've seen that in teeny tiny towns in Argentina. I think that's almost a deliberate function of how government works and maybe is supposed to work. But when I'm trying to pitch somebody on the value of this, because I'm not working with highly technically oriented people, I try to work from examples and make it really concrete for them. And in fact, I find that talking about cloud native and the jargon and stuff can be off-putting, right? Because people hear that and they think, oh, this is too technical for me. And it's really not. And in fact, I came to cloud native because I'm a little bit lazy. I think everybody who works as a programmer is a little bit lazy. Otherwise, you would be fine just clicking 1,000 times to do the thing instead of writing the script, right? I got into cloud native because it was way easier than spinning up a PostGIS database, right? And I could just serve PM tiles, and that made my life way easier. And I try to approach it the same way, that when I'm talking to people in municipal government, I'm not like giving them some spiel about latency. I'm showing them how much easier it makes their lives and how little it disrupts stuff. So, for example, I was in this town in Argentina called Esperanza. We were doing some work on flood risk analysis, right? And totally tangentially, just kind of like on a whim, I showed their GIS analyst how to pull the building footprints data, right? It's a town of about 45,000 people. And, we pull them in Python. It takes maybe 2 minutes, ballpark. And Kaito, the GIS analyst, looks at me and she's like, well, I was working on this with an intern. I'd been given high resolution satellite data from the state government, and this was going to take me months, right? Like months of work that you just erased in 2 minutes. And that's the kind of stuff that I come back to when I'm trying to pitch this stuff. It's those demonstration projects of like, this isn't scary, and this is going to make your life way, way easier. That's what I always kind of circle back to.
Interesting. Now that you have those building footprints and that high resolution satellite aerial imagery, now you can start to think bigger than just let's draw boxes around these houses. Like, how big are these houses, for example? How many people might live in there per square meter? What is the roofing material made of? You can really start to see how, instead of doing this relatively simple work that's, by the way, it's already done for you in these global data sets, you can start to think beyond that. That's really, really interesting. Hey, does the choice of platform matter here? So we're in terms of adoption, so you mentioned Python there. We've talked about QGIS. Does that matter?
It matters, depending on your audience. But I think in my work, I keep trying to think about where people are, right? I love Python and I love R. I love Python in particular because it's what I work in. But when I got down to Argentina, I found that nobody was in Python. Everybody's in QGIS, right? And that's just the reality. That is the lay of the land. And in many ways, that's a big win. I mean, when I think about like working with QGIS versus Esri products, I would much rather everybody be in QGIS. So that was really gratifying to see. And it has shaped how I've worked on stuff. As much as I want to hand people a Jupyter notebook and be like, go wild, I recognize that my constituency, my users are in QGIS, and I try to build accordingly. And I don't think that's necessarily a negative thing either. I tend to have kind of a programmatic approach, and I love scripts because they're reproducible, but also it's a big win that people are in QGIS. We've invested a lot of time and effort and money in getting people to use that tooling, and they're there, and we should be excited about that and build for that. And I think that's become also trivially easy. A couple of months ago, I vibe coded an app, the first ever app or plugin, I guess, to access the Argentine national census in QGIS. It's been a problem for like 15 years, and it's a huge pain in the butt to access the Argentine national census because it's in this weird software format that requires you to like download some database thing and then copy the data out into Excel and then join it to a shapefile in QGIS. And it's like a huge hassle. And I looked at it for about 20 minutes when I was there and got sick of it and decided I was going to extract the data and stick them in a Parquet file on Source Cooperative. And that's what I did. And from there, it was like, an afternoon of vibe coding to put together a DuckDB wrapper, basically in QGIS, that pulls in all the data in a couple of seconds. And that's the kind of thing I think we can work toward. Like the underlying, the back end, so to speak, is just Parquet files, right? Vibe coding a DuckDB wrapper is like the easiest thing in the world now. If I had stopped at sticking them up on Source Cooperative and Parquet files, nobody would be using it, right? And now there are hundreds of downloads. It has more downloads than the entire membership of the largest geospatial Telegram channel in Argentina, which is like where most of the folks in the geospatial world are. I have friends who are like sharing it with professors at their universities and stuff, and it's the first ever, app to do or plugin to do this. And if it weren't in QGIS, it wouldn't be useful, right? Because it would be a dead end. Stopping at the Parquet files would have been a dead end. So I think meeting people where they're at is really, really crucial. And it's, again, worth celebrating that they're in QGIS and not ArcGIS, for example.
I think for me, the take-home message here is like, if you build it, they won't come. You need to do something else. So in your case, you put it on a platform that already had a lot of attention, so it already had distribution, and you win, right? But you also told people about it. Hey, look at this thing here. So I think in Geo, we could be a lot better at that. I'm sure that there is a billion amazing projects on GitHub, but they built it and then they did nothing for the most part. Or maybe they just weren't looking for mass adoption. But I really wish people would put more of an effort into marketing, to talking about the things that they've done. I realize it's really hard for a lot of technical people. They would rather not. But if you really want to have impact, I think this is the crucial next step after building something. Do you know much about the Esri world? I'm wondering about their adoption in cloud native. And it's fine if you don't. I know nothing about it myself.
I'm not remotely an expert on it, but I see a lot of stuff on LinkedIn, for example, about them adopting, this kind of stuff and building tooling for DuckDB and Parquet and Esri, which I think is great. I think that's a sign that we're really on the path to some kind of meaningful adoption. Maybe this is optimistic of me, but I think we're 2 to 3 years out from this being kind of standard, industry standard stuff. I know that companies like Whereabots and Overture Map Foundation stuff are pushing really hard, and maybe I have a slightly optimistic bias based on that being kind of my cohort of folks that I interact with. But I really do feel like we're kind of in this moment where the adoption gap is closing, and industry behemoths like Esri are realizing that this is a big opportunity and that this needs to be standard. And I'm excited about that, because I think that interoperability thing is a major thing that needs to shift for this to be viable beyond just our little corner of cloud native geo. I think once Esri has that support, when it's in QGIS and that kind of stuff, that's when it becomes viable to see mass adoption.
Yeah, that'll definitely accelerate things. There's no question about it. And speaking of marketing, like if Esri does marketing, right? They create something and they tell people about it. And I think in a lot of ways they move the industry because of that. They might be a little bit slow to the party sometimes, but when they do something, they talk about it and they spread the word and they create content around it. Yeah, they do marketing for it. And we could probably learn something from that. You talked about vibe coding an app to do this, AI vibe coding. Let's have a conversation around that. Is this going to change the way we think about cloud native? I think it's going to change what is possible. I think we're heading towards a world of personalized software where people are going to do exactly what you did. Oh, I've got a problem. I'm not going to wait for somebody else. I'm just going to do the thing. I wonder also if it's going to change or lessen the discoverability problem. where instead of having to search through Google, I realize that a lot of these LLMs have a similar problem. There's a lot of information out there, which is the best information kind of thing. That's a problem that they too have to solve. Do you have any thoughts around that? Do you think it's going to be a game changer in any way, shape, or form?
I think it can be if we use it well. The sort of bullish take, the really optimistic take is that with really good metadata and an agent-first mindset, that we can do a ton to make these tools and these data sets more discoverable. I think it was Samapriya Roy, and I forget his co-author, but he and a co-author published a paper maybe a year ago talking about precisely this, about including better metadata in anticipation of LLM discoverability, to think about how data sets should be used, to make it really easy for people to be like, hey, I'm trying to do a climate risk analysis for my city, and I need to think about climate change projections and what temperature metric, if I only use one metric, what should I use and where can I find that data? To then be able to really quickly look through a catalog and find that data and use it. And it's really cool to see people kind of figuring this out in real time with MCP servers and that kind of stuff. So I think there's a ton of potential there, and I'm really excited to see how pretty simple chat interfaces can help make these tools a lot more discoverable, especially as we figure out the sort of most rigorous ways to do that with guardrails. But then there are two kind of potential pitfalls there. One is just simply remembering that like most people in the global south, for example, do not have access to the same tooling that we do, right? I'm chewing through Claude Code tokens at just a ludicrous rate, like irresponsible. And then I think about my colleagues back in Argentina who are like copy and pasting stuff into ChatGPT like I was in when it first came out and I was still figuring out how to use it, and they're on the free version and stuff. And like, it's like we're operating in different universes. If we forget that those users exist and we don't accommodate them in our tooling, then we're just going to create new moats of inaccessibility. It's like, cool, we've moved the needle on the power of this tech, but we've continued to leave these people behind. So we need to continue to think about them as users and think about how AI can make this stuff more accessible to them too, strategically. And then the other risk is one that I think you kind of alluded to earlier, which is like siloing, basically. It's like, I spent my weekend vibe coding this cool thing and I put it up on my GitHub page and then I made a LinkedIn post, and I'm not going to do any effort to like figure out what else is out there. Like I kind of had this experience with the census app. I had done all this work to like clean and optimize the data and stick them on Source Cooperative. And like every decision that I made about the Parquet optimization and the hosting on Source Cooperative as opposed to other places was really deliberate. And then a couple weeks after I published this thing, I saw some other guy who had published a similar one. It was a Python package to access my same data that he'd moved over to Hugging Face, which is great, but he dropped the geospatial component. And he has no idea that like I work closely with Jed, and Jed is fine with me keeping these data up on Source Cooperative indefinitely. And I think about things like metadata and stack catalogs and stuff. And he's just like got these flat files up there with minimal documentation. That kind of splintering, as much as I'm excited to see people, taking this project and spinning off of it, which is great, that kind of siloing and fragmentation, that's going to hinder development. We should be collaborating rather than splintering. And that's my kind of fear with the power of AI coding, is that we all are in our little GIS silos, not talking to each other.
Yeah. Because it's exciting to build your thing, right? It's exciting to be the maker of stuff. I totally get that. And I am guilty of that as well. I wonder though, I see what you're saying about remembering that not everyone has the same access to let's say Claude tokens as what you or I do. And that's fair. It would also be fair to say not everyone is an expert in Python, but they have this tremendous opportunity to take their expertise and give it to people that are not experts, and then they have access to. They have the tooling as well, and to create things for other people. So that has definitely gone up and to the right as well. Maybe this is a good way of sort of rounding off the conversation. I realize you alluded to a little bit to your thoughts around this before. You said you're an optimist. Where do you think we're going to be in 5 years with this? What do you think will have changed?
I mean, it's so hard to say given the pace of things. It's really hard to predict.
Okay, let me put it another way. Will cloud native be more or less important in the future?
Cloud native is going to be the water that we swim in, right? It's going to be the air that we breathe, I think, for geospatial. I think the bigger question is almost like, at what point does it become obsolete? And maybe that's like almost an overconfident answer, but to me, it feels inevitable at this point that cloud native is the stack, because it's simpler, it's easier to use, it's more scalable, it integrates with everything, and I think we've solved most of the technical problems behind it, right? So the question now is like, how do we disseminate it more widely? And I think within 5 years, I have very little doubt that it will become the industry standard, and people still using shapefiles will get funny looks like, what are you doing?
They don't already?
Right. Yeah. Well, they certainly do for me. So I wonder more like, where do we take it next? Right. Like in 5 years, I think we're going to be taking for granted that everybody is storing their vector in GeoParquet and their raster in certainly cloud optimized GeoTIFF and maybe in ZAR. The enthusiast in me is kind of wondering, all right, what do we do next? Right. Like, this is great. What are we on to next?
It will be interesting, just like AI. So, AI this, AI that. We use deep learning to do whatever we're doing with it. I'm pretty confident in the future we won't be saying that. We'll just be, I did some analysis, and of course I used AI to do it. In the same way, we don't talk about digital cartography anymore. We talk, I made a map, and of course I used a computer to do it. I can see cloud native going the same way. Yeah, I just stored the files. I just that is the stack, like you were saying. That being said, I can see use cases where unless it becomes read and write, I can see use cases where we're still going to need to do things in a similar way that we're doing them today, or we're going to have another approach. But I can't see it unless it becomes writable. I don't believe it is at the moment. Yeah, I can see that being a barrier for some particular use cases.
What do you mean by writable?
Yeah, that we can write to it. Can we write to Parquet?
Oh, yeah. Yeah. Yeah.
No, but like if you make a file and I put it and you put it somewhere and I read it, make my range requests, make a change to that, can I send it back to that file?
Yeah, assuming you have write access to the bucket. Yeah. And we have one of the cool projects that like I know Carto is working on is geospatial support in Iceberg to have like multi-user access, admin privileges, concurrency, asset rights, all this kind of like more sophisticated power user stuff. I do think those questions of like working with it at scale, for multi-users, for a Carto level user, those are still kind of being hashed out, but I think we're pretty close to solving those kinds of questions.
But I'm talking about not just writing to the bucket, like adding a new file. I'm talking about that information that you stored as the file in the bucket somewhere. I download that and I enrich it and send it back and update that chunk of data.
I think it would just append to the file. So Iceberg works by being append only, right? I have a very loose understanding of Iceberg, but you basically append to a Parquet file, and then there's like a manifest that references the current version of the file. So I think that's probably how you would do it. There's probably a way to do it with regular Parquet, but I think Iceberg's probably the answer to what you're talking about.
Cool. Well, I stand corrected, and happily so. That sounds really interesting. I'll have to dig into that. Nisam, thank you very much for your time. I really appreciate it. Really enjoyed the conversation. I wish you all the best with your work, and I really appreciate the service that you're doing. It's fantastic. You're making a difference.
Thanks. Yeah, and really good to be here, Daniel.